The moment of truth for the interstellar visitor 3I/Atlas had arrived. For weeks, the object had defied easy classification, presenting a baffling array of contradictions. Chemistry that refused to cooperate with its visual activity, a flight path too smooth for it apparent outgassing, and potential, haunting alignment with the most famous unexplained radio signal in human history. Every anomaly, every contradiction, had been leading toward this single critical moment. Perihelion. Perihelion is a point in an orbit where a celestial body comes closest to the central star, a time of maximum thermal stress, maximum energy input, and for comets, maximum expected activity. This was the cosmic crucible, the test that would force Atlas to reveal its true nature. The scientific community waited, confident that under the intense pressure of the sun, the object would finally conform to the laws of cometary physics, or shatter every assumption we held about interstellar matter. What transpired as Atlas reached its closest approach to the sun was not a confirmation of known laws, but an event of such profound and fundamental contradiction that it immediately shook the foundations of astrophysics. An unprecedented occurrence was detected across multiple observatories, an anomaly that did not just fail to match known cometary behavior, but actively performed the inverse of what physics demanded. The object that had been steadily defying our models since it first entered our detection range now exhibited its most dramatic and unnerving transformation. This was not a subtle deviation. It was a cosmic U-turn, a direct contravention of the expected relationship between heat and activity. And what we observe in that intense solar glare forces us to reconsider the very mechanisms that govern interstellar objects, opening the door to the most uncomfortable possibilities. The anticipation had been immense. Every available telescope, every orbital asset, and every radio dish was focused on the tiny, enigmatic object. NASA's Solar Dynamics Observatory, designed to study the sun itself, the European Space Agency's solar orbiter, ground-based observatories spanning 3 continents, all converged on a region of the sky where Atlas was making its fiery rendezvous. Scientists expected a surge of activity, the ultimate show of cometary fireworks, where the maximum solar heating would unleash massive jets of gas and dust, causing the coma to swell to its maximum size and its brightness to peak. The object was deep inside the orbit of Earth, close enough to feel the sun's radiation intensifying dramatically, exponentially. The physical reality dictated that the surface temperature must spike and subsurface ices must vaporize rapidly. But on October 29th, at precisely 1,400 hours Universal Time, as 3I/Atlas achieved its perihelion distance of 0.7 astronomical units, the moment of maximum expected activity brought forth the most unnerving event of the entire observation period. The object went quiet. The activity that had been steadily building for weeks, the faint but observable sublimation and outgassing, suddenly ceased. The coma, which had been expanding, contracted dramatically. The brightness, which should have reached its maximum peak, dropped by an astonishing 40% in less than 6 hours. Atlas had not just failed to follow the expected pattern. It had performed the exact opposite maneuver. It was as if the interstellar visitor had actively detected the surge in solar radiation and responded not by melting, but by turning itself off. This is the single, starkest contradiction of the entire study, a phenomenon for which there is no comfortable or known explanation in the vast database of cometary physics. The observation of 3I/Atlas at perihelion, the point of maximum heat exposure, and its subsequent immediate shutdown of activity stands as a profound violation of one of the most fundamental principles in cometary physics. The laws governing the behavior of these icy bodies are derived from simple, inexorable thermodynamics. When a volatile material is subjected to increased heat, it vaporizes more quickly. This relationship is codified in the inverse square law of solar radiation intensity. As an object halves its distance to the sun, the energy it receives quadruples. At $0.70. Closer to the sun than Earth, Atlas was bathing in a near maximal thermal environment. Every model predicted an explosion of activity, a dramatic and sustained outgassing event. Instead, the universe presented us with an inverse result. We witnessed maximum solar heating resulting in minimum observed activity. This is the core anomaly that forces a paradigm shift. The sudden, dramatic drop in brightness, the 40% reduction within a mere 6 hours, was a physical manifestation of this inverse behavior. Brightness in a comet is directly proportional to the amount of dust and gas released, which forms a coma. A drop in brightness signifies a rapid and unexpected reduction in the rate of volatile sublimation. The object was effectively sealing itself against a solar furnace, a mechanism that does not exist in the natural geological or chemical processes of a heterogeneous body of rock and ice. The conventional explanations for a comet's behavior at perihelion are robust. The increase in surface temperature should overcome the latent heat of sublimation for various ices. First water, then $CO, then $CO_2, leading to a cascade of gas and dust release. This activity should be sustained and should accelerate as long as the object remains close to the sun. A shutdown requires a mechanism that either instantly changes the object's surface composition or somehow redirects the incoming thermal energy. The implication is deeply unsettling. Natural objects do not regulate their activity based on external conditions. A chunk of rock and ice has no feedback loop, no internal mechanism for making decisions about energy management. It simply responds passively to the laws of thermodynamics. Yet, Atlas's behavior suggests an object that detected the sharp increase in solar radiation and executed a response to maintain equilibrium by reducing the observable output. This level of self-regulation, of active environmental control, is the hallmark of an engineered system, not a natural phenomenon. The core of the mystery is here. We observed a system that, under maximum stress, demonstrated properties that fundamentally belong to the domain of technology, not geology. The shutdown at perihelion is the single strongest piece of empirical evidence suggesting that Atlas is operating outside the known and predictable bounds of classical cometary physics. The consequences of accepting this observation demand a complete reevaluation of every prior assumption made about the interstellar visitor. To fully grasp the magnitude of the perihelion anomaly, one must appreciate the stark mathematical reality imposed by the inverse square law and how 3i/Atlas's behavior offered a direct, observable contradiction. The inverse square law dictates that a physical quantity, such as solar radiation intensity, is inversely proportional to the square of the distance from the source. As Atlas approached the sun from $1 Australian, Earth distance, to $0.70 perihelion, the intensity of the solar energy slamming into its surface increased by a factor of over 2, a massive thermal spike that should have guaranteed maximal volatile release. This is not a theoretical model. It is an undeniable physical certainty in the solar system. The expected cometary behavior, the proportional response, is a direct reflection of this energy input. As the square of the distance shrinks, the rate of sublimation should skyrocket, leading to a commensurate increase in the size of the coma and the total observed brightness. The fact that Atlas exhibited inverse behavior, maximum input leading to a rapid, sustained decrease in output, means that an unknown, powerful force or mechanism must have actively counteracted the massive influx of solar thermal energy. This is a scientific absurdity under normal conditions. It is the equivalent of ice water freezing when placed in boiling water. For a natural object composed of a heterogeneous mix of rock, dust, and ice, there is no physically plausible passive mechanism for such a rapid, coordinated shutdown. If the object were made of highly insulated material, the shutdown would be slow and gradual, as thermal energy slowly penetrated subsurface. Atlas's drop was rapid, dramatic, and global, suggesting a change that occurred uniformly across the visible surface. Theories invoking a temporary formation of a super-hard, non-volatile dust crust were immediately problematic. Such a crust would require an instantaneous fusion of dust grains, an energy-intensive process that should also have increased activity first, not decreased it. Furthermore, the heat trapped beneath such a crust would eventually cause a massive, violent outburst, a predictable, delayed reaction that was not observed. The only way to reconcile the inverse square law with the inverse behavior is to introduce the concept of active thermal management. The object must possess the capability to receive the increased energy and deliberately choose where that energy goes, redirecting it, absorbing it internally, or converting it into an unobservable form. This implies a non-passive system, one with internal controls, sensors to detect the external solar flux, and a mechanism to execute a uniform, protective response. This profound violation of predictable laws of thermodynamics under maximal stress is a core empirical observation that pushes the discussion toward the uncomfortable possibility of an engineered, rather than a natural body. The physics of the solar system demands a proportional response. Atlas delivered an intentional one. As 3I/Atlas went physically quiet at perihelion, the nature of its residual activity became a focus of intense spectroscopic analysis, and the data soon revealed a chemical mystery that was just as profound as its dynamic anomaly. Spectroscopic instruments, the tools of astrochemistry, analyzed the light emitted by the comet's coma to determine the composition of the gases being released. During the approach phase, the spectra were strange but somewhat recognizable. Emission lines consisted with water vapor, carbon monoxide, carbon dioxide, and various simple organic compounds. It was peculiar chemistry, but still chemistry. However, at the moment of perihelion's shutdown, those recognizable emission lines changed dramatically. The spectral signature that emerged from the diminished coma was no longer a simple variation of standard cometary outgassing. New, complex molecular signatures appeared that had not been detected during the approach phase. Researchers identified lines consistent with complex hydrocarbons that were difficult to explain in the harsh radiation environment, and more importantly, various complex nitrogen compounds, molecules not commonly associated with cometary sublimation. The emergence of these complex molecules at the moment of maximal thermal stress, rather than the simpler, more volatile components, was a deep chemical contradiction. The most baffling discovery, however, lay in a cluster of emission lines that simply did not match any known molecular species in humanity's vast spectroscopic databases. Dr. Robert Work, a leading analyst at the University of Hawaii, spent 12 continuous hours rigorously comparing the perihelion spectra against every known molecular signature, every comet, every asteroid, and every meteorite sample cataloged by science. The result was uniform, no match. The wavelengths did not correspond to any stable, known molecule that can exist under laboratory conditions or that has ever been observed in the vast emptiness of space. This unprecedented chemical revelation forces a radical conclusion. Either we are observing exotic chemistry that can only occur under the extreme conditions of a distant, foreign stellar system, producing molecules entirely unfamiliar to the chemistry forged in our solar nebula, or we are observing signatures that are not the result of natural chemical bonds at all. This might include emission from highly stable, non-terrestrial materials, or, more radically, the spectroscopic signature of non-chemical, artificial processes, perhaps exhaust byproducts or energy conversion emissions from an engineered system. The spectroscopic shift at perihelion means that even in its quietest state, Atlas was screaming a message of alien origin. It suggested that the intense solar radiation at closest approach did not just trigger a thermal reaction, it initiated a chemical transformation that revealed the complex, non-standard nature of the object's core. The detection of molecular species that defy current classification is a profound scientific challenge, confirming that Atlas is a physical sample of the galaxy that actively transcends the chemical boundaries of our local cosmic neighborhood. The discovery of molecular emission lines in the perihelion spectra of 3I/Atlas that do not match any known species represents a singular moment in astrophysics, challenging the very completeness of our chemical understanding of the universe. This finding transcends a mere categorization of comets. It suggests that there exists a chemistry, a set of molecular bonds, elements, and stable structures that is not reproducible in Earth-based laboratories and has never been observed in the vastness of the cosmos previously surveyed. The question becomes, what does it mean for a molecule to be unknown in this context? It implies that the matter composing Atlas, and specifically the gases released during its highest stress state, was forged under conditions utterly foreign to our experience. Consider the possibility of exotic isotopic ratios, elemental building blocks that are chemically familiar but possess neutron counts far outside the stable norms of our local solar system. Such ratios could shift the expected wavelengths of molecular emissions just enough to render them unmatched against terrestrial databases. This speaks directly to the nature of the star system where Atlas originated, suggesting a progenitor star with a radically different nucleosynthesis history than our Sun. A more radical chemical hypothesis involves non-standard bonding. Could the intense thermal and radiation environment of the interstellar medium or the exotic pressures of its parent system have allowed for the creation of unique, highly stable polymer chains or crystalline structures that use common elements, carbon, nitrogen, silicon, but bond them in ways we have never mapped? These compounds will behave differently under the sun's glare, only releasing their unique signatures when subjected to the ultimate thermal stress of perihelion, precisely when Atlas went quiet. The complex nitrogen and hydrocarbon compounds observed alongside the unmatched lines hint at a sophisticated and durable chemical architecture. The most profound implication, however, returns to the possibility of artificial origin. Could these unmatched lines be the spectral signature of a non-chemical process, such as electrical discharge or the exhaust from a reaction that uses propulsion or energy conversion systems beyond our current technological grasp? If a molecule does not exist in nature, the next most logical source is manufacturing. The fact that these lines appear precisely at the moment of maximal stress, when the object performed its regulatory shutdown, suggests that this unknown matter or process was activated by the sudden influx of solar energy. The process of decoding these unmatched molecular lines is now a top priority for astrochemistry. It requires an international, multidisciplinary effort to simulate and model complex chemistry under extreme conditions, extending beyond the conventional dihydrogen monoxide-dominated models. Until a stable, natural molecule can be identified that corresponds to these wavelengths, the unknown spectral signature of Atlas remains one of the most compelling pieces of evidence for its fundamentally alien nature, a direct chemical challenge from a star system we have never known. The observational data from infrared telescopes regarding the thermal signature of 3I/Atlas at perihelion introduced a geological impossibility that profoundly deepened the mystery. When any natural, irregular body composed of varied materials, like a comet of rock, dust, and ice, is heated by the sun, the physics dictates that its surface temperature must be heterogeneous. This is because hotspots form based on the object's geometry, the angle of the sunlight, and the differing thermal conductivities of its constituent materials. Darker patches absorb more heat than brighter ones. Dense rock holds heat longer than porous ice, and shadow crags remain cooler than sunlit peaks. Temperature variations across the surface should be substantial and irregular, a natural consequence of chaotic formation and composition. Atlas, however, presented a thermal lie, a degree of surface temperature uniformity that is physically impossible for a natural, irregularly shaped object with varied composition. Infrared observations showed the entire visible surface maintaining the exact same temperature within a deviation of only 2 degrees Kelvin. This is an absurd level of thermal homogeneity for a comet-like body exposed to the intense, directional radiation of the sun at $0.70. It violates basic principles of heat distribution for heterogeneous solids. For comparison, a natural asteroid of this size would show temperature differences of tens, if not hundreds, of degrees between its sunlit and shadowed sides. This impossible uniformity leaves scientists with 2 radical, uncomfortable interpretations, neither of which supports the standard cometary model. The first interpretation is that the object is made of a single, perfectly homogeneous material, a massive, solid crystal, or block of single, exotic substance with uniform thermal conductivity. However, this contradicts the spectroscopic analysis, which showed varied and complex chemical signatures, indicating a non-uniform composition. A single material body simply cannot release carbon dioxide, water vapor, and nickel simultaneously, as the spectral data suggests. The chemical complexity argues against the physical simplicity. The second interpretation, and the one that has caused the most alarm, is that the object is employing active heat distribution to maintain such perfect thermal equilibrium across an irregular, externally heated surface requires a mechanism that is actively moving thermal energy around. This demands internal systems, a form of liquid circulation, perhaps, or a complex array of thermal management technology. The object must be able to detect hotspots, calculate the necessary energy transfer, and execute the movement of heat, effectively acting as a massive, self-regulating radiator. This is a property of engineered systems, not inert chunks of ice and rock. No known natural process can achieve this level of thermal stability and control on a body of this size and composition. The uniform temperature profile is therefore a profound contradiction. It is an observation of thermal signature that can only be achieved through intelligent design or active internal management. The thermal lie suggests that the core of Atlas is far from a passive, frozen nucleus. It hints at a body with internal structure and function, actively working to maintain a stable operational temperature under maximum thermal stress, a necessity for any sophisticated machinery, but an utter impossibility for a piece of cosmic debris. The thermal anomaly observed on 3I/Atlas, the impossible uniformity of its surface temperature at perihelion, demands an explanation rooted in active management rather than passive geology. This hypothesis suggests that the object is not merely resisting the sun's heat. It is utilizing a system to efficiently distribute or convert that energy, a mechanism that inherently points toward internal complexity and functionality. The necessity for internal heat distribution stems from the simple physics of an external energy source coupled with a heterogeneous, non-rotating body. For a natural, non-homogeneous object, the only way to achieve near-perfect surface temperature equilibrium would be through extremely rapid rotation, which would effectively smear the heating over the surface. However, the measured rotation period of Atlas is not fast enough to account for the observed uniformity. This leaves the internal structure as the only plausible explanation. The thermal energy hitting the sunward side must be actively transferred to the cooler, anti-sunward side to maintain the balance, resisting the massive external thermal gradient. One hypothesis for this active management involves internal convection. If Atlas possesses a highly porous interior, perhaps the carbon dioxide or other volatiles could be circulating as a gas through these channels, acting as a massive heat exchanger, absorbing heat from the sunward side and releasing it on the cooler side. While physically possible, this would require a massive, open internal structure and a specific gas density that would complicate its dynamic stability and would likely result in an asymmetric outgassing, a phenomenon that was not visibly observed. The efficiency required to maintain a 2-degree Kelvin stability across a 400-meter body under maximum solar flux would be extraordinary for a purely passive convective system, requiring a level of perfection that stretches the boundaries of geological possibility. The more radical, yet cleaner, explanation is that of thermal management technology. This suggests the presence of internal liquid circulation systems or advanced, high-efficiency heat pipes designed to distribute thermal load. Such systems are mandatory for complex spacecraft and terrestrial reactors to prevent catastrophic failure from localized overheating. The object would need sensors to detect the thermal gradient and a mechanism to pump or circulate the working fluid, essentially turning Atlas into a massive, self-regulating thermal engine. This is not a guess. It is a deduction based on the observed thermal output. The uniformity is not a random feature. It is an operational requirement. The necessity of internal heat distribution transforms the object from a passive target into an active system. It suggests a function beyond mere survival. Maintaining a uniform temperature is often required for the stable operation of sensitive electronics, instrumentation, or power generation systems. The object's defiance of the laws of passive heat transfer suggests that the true complexity of Atlas lies hidden beneath its deceptively simple, cold surface. This singular thermal anomaly is a powerful call to action, demanding a mission that can finally penetrate the surface to reveal machinery that must be operating within to enforce this unnatural equilibrium. The behavioral anomalies of 3I/Atlas at Perihelion were further compounded by a visually staggering change in its surface properties, an unprecedented albedo flip. Albedo is a measure of an object's reflectivity, how much solar light it reflects versus how much it absorbs. This property is determined by the surface material and texture and is typically extremely stable for celestial bodies. Yet, during its closest approach to the Sun, Atlas's albedo shifted dramatically, increasing from a very dark $0.04, typical of a coal-black dead comet, to a bright $0.09, effectively doubling its reflectivity in less than 8 hours. This rapid change occurred with precision that defies natural chemical or geological processes. This rapid and significant change is an impossibility under normal cometary physics. For a comet to increase its reflectivity or brighten, it must expose fresh, clean subsurface ice. This process is inherently linked to increased outgassing and activity. The sublimation of volatiles must drag away the dark, overlying dust crust, revealing the bright ice underneath. The result should be a brighter object with a vastly expanding coma. Atlas, however, executed the inverse. It got brighter while simultaneously reducing its activity and contracting its coma, violating the cause and effect relationship that links brightness and volatile release. It is a perfect contradiction. A visual change indicating increased activity, coupled with physical measurements showing the exact opposite. To put the magnitude of this change in perspective, changing a natural celestial body's albedo that much in such a short period would require a massive, rapid transformation of its surface composition or texture, covering or exposing a significant portion of its total surface area with radically different material. In the context of Atlas's observed behavior, this phenomenon suggests that the physics simply does not work unless the surface itself was actively restructured by a non-geological process. The speed and scale of the change require a mechanism that can rapidly and uniformly alter surface properties. The impossibility lies in the combination of events: increased brightness plus decreased activity. If the object were a normal comet, the reduction in activity would imply the formation of a dark, non-volatile crust, which would decrease the albedo, making it darker. The fact that Atlas became brighter while shutting down means that a bright, highly reflective material was deployed or exposed without the aid of massive, visible volatile ejection. This forces us to look beyond simple chemical sublimation. This observation leads directly to the hypothesis that the surface properties were changed by a process that is independent of internal ice sublimation. The rapid albedo flip suggests a form of deployable or reconfigurable surface elements on Atlas, a deliberate, engineered response to regulate the amount of solar energy absorbed by the object during its most thermally intense transit. The albedo flip, therefore, is a powerful piece of visual evidence suggesting not just passive resistance, but active surface management, a concept entirely alien to the physics of natural celestial bodies, and a clear indication of a system controlling its interaction with the Sun. The albedo flip observed on 3I/Atlas, the doubling of its reflectivity in mere hours without the attendant loss of mass expected from cometary sublimation, pushes the discussion squarely onto potential of engineered surface restructuring. Since the phenomenon cannot be explained by the natural exposure of subsurface ice, which would be accompanied by explosive outgassing, the change must be attributed to an independent, active process on the surface of the object itself. The core question is whether the surface change can be linked to a natural, exotic phenomenon or whether it points exclusively toward technology. The existence of thermochromic or electrochromic materials provides a strong technological parallel. These are substances whose reflective and color properties change in response to external stimuli like temperature or electrical current. We utilize them on Earth for smart windows that automatically tint in the sun. If Atlas were a natural object, it would require a mineral with an intrinsic, rapid, and uniform thermochromic property that is not only triggered by the maximum solar flux, but also capable of covering a massive geological surface area. While the universe is vast and unknown mineralogy is possible, the existence of such a material that is also chemically consistent with the object's other spectral anomalies is a stretch of probability that strains credulity. The simplicity of the engineer hypothesis is compelling. A deliberate increase in reflectivity at perihelion is the most rational protective response for a delicate system subjected to massive thermal overload. By doubling its albedo, the object instantaneously halves the amount of solar energy being absorbed by its core. This suggests the deployment of reflective panels or the activation of a surface coating designed for this precise moment of thermal stress. This would be a form of active camouflage or thermal shielding, a process entirely detached from the underlying geological composition and solely dedicated to survival and energy management, a calculated move to reduce the thermal load. Furthermore, the restructuring is likely linked to the other anomalies. The albedo flip, which regulates the absorbed heat, directly supports a uniform temperature anomaly, Chapter 6, which suggests that the absorbed heat is efficiently managed. An engineered surface would function as the first line of defense, reducing the need for massive internal heat distribution systems. The entire suite of observations, reduce activity, uniform temperature, and increased reflectivity, forms a coherent, interlinked system of thermal regulation that defies the passive nature of known celestial bodies. This is not a random collection of strange events, but a synchronized response. This phenomenon is a direct challenge to the notion of natural surface evolution. Surface restructuring on this scale and speed is a property of controlled systems, not inert geology. The albedo flip is perhaps the most visually explicit evidence suggesting not just passive resistance, but active surface management, a concept entirely alien to the physics of natural celestial bodies, and a strong indicator that the object possesses internal, functional components. As if the combined chemical and thermal anomalies were not sufficient to redefine the boundaries of possibility, a final, deeply troubling piece of evidence emerged from the data gathered by NASA's Parker Solar Probe. This spacecraft, designed to fly closer to the Sun than any object built by man, was positioned to take magnetometer readings as 3I/Atlas passed through perihelion. The data confirmed the existence of a highly unusual and completely unexpected phenomenon, a distinct structured magnetic field anomaly emanating directly from the interstellar object. The detection of a magnetic field around a comet is not entirely shocking. The interaction of ionized cometary gases with the Sun's solar wind can induce weak, temporary magnetic fields. However, the field detected by the Parker Solar Probe was not the expected, weak, induced magnetism. It was a localized, structured magnetic field emanating from the nucleus itself. Furthermore, its strength was measured at approximately $0.03 nanotesla, a staggering distance of 2 million kilometers. For a small 400-meter object to generate a detectable magnetic field at that enormous range requires a power source and configuration far beyond anything explainable by residual planetary magnetism or simple ionization. To generate a structured, detectable field at that distance, Atlas would either need to be constructed from extremely rare, highly concentrated ferromagnetic materials in a specific, non-random configuration, or would require the presence of massive, flowing electrical currents. Neither explanation makes sense for an inert chunk of rock and ice. While a destroyed planetesimal could contain metallic cores, the arrangement and strength of the field pointed away from passive remnants and toward an active source. The strength and structure of the field suggests a deliberate, powerful internal generation system rather than a chaotic geological feature. The most disturbing aspect, however, was not the existence of the field, but its behavior. The magnetic field was not constant. It pulsed with regular, highly predictable oscillations. These pulses occur with a precise period of 4.7 seconds. Natural magnetic fields do not pulse with such clockwork regularity. Pulsars, which are rotating neutron stars, exhibit regular pulses, but those are governed by the extreme physics of a dead star. Magnetic field oscillations in a smaller body require changing current flows, varying electrical activity, or the precise rotation of a magnetized source. This regularity implies active, control processes within the object, a timing mechanism operating with extreme stability. The magnetic field, therefore, is the first piece of evidence that is almost impossible to explain away with exotic natural geology. The combined presence of a structured, strong, and rhythmically pulsing magnetic field suggests the presence of power generation or communication systems. The rhythmic nature of pulse, the 4.7-second period, is highly suggestive of a deliberately timed, non-natural phenomenon. The Parker probe, designed to study the sun, provided a subtle, unsettling whisper that Atlas is not just a geological puzzle, but potentially a powered, functional system, beating out an unnatural rhythm against the quiet physics of the cosmos. The most unsettling aspect of the magnetic field data gathered by the Parker Solar Probe was not the field's existence or its strength, but its precise, rhythmic oscillation. The discovery that the field emanating from 3I/Atlas pulse with an unwavering period of 4.7 seconds introduced a metric that directly contravenes the physics of natural celestial bodies. In the realm of inert geology, variations in a magnetic field are chaotic, irregular, and driven by random external interactions or the turbulent rotation of a large body's metallic core. A small, non-planetary object like Atlas should not exhibit a magnetic rhythm. This regularity implies a source that is being controlled, modulated, or generated by a mechanism that possesses both power and timing. This is the difference between static and music. The fundamental contradiction lies in the concept of regularity itself. In physics, a predictable, clockwork oscillation implies a resonant frequency, a rotating structure, or controlled power cycle. If the pulse were due to rotation, the object would have to possess a strongly magnetized area that was constantly being swept past the Parker probe's magnetometer. However, the rotation period of Atlas, as measured by optical observations, does not match the 4.7-second pulse cycle. This rules out simple rotational effects. Furthermore, the pulse was highly localized and maintained its frequency despite the rapidly changing distance and angle between Atlas, the sun, and the probe, a stability that defies the expected distortion from the surrounding solar wind. The rhythm was self-sustained and independent of the external environment. The only known natural sources in the cosmos that exhibit such precise, non-rotational pulsing are associated with extreme physics, such as pulsars, highly magnetized, rotating neutron stars whose immense mass and rapid spin create an electromagnetic beacon. To suggest that a small solid object like Atlas could mimic this precise behavior on a small scale requires the presence of highly controlled, varying electrical currents within its structure. These currents would need to be intentionally switched on and off or routed through different parts of the body to generate the observed oscillation. This demands an internal power source and an active timing system to maintain the unwavering 4.7-second period. This implies a deliberate, artificial clock ticking inside the object. This rhythmic pulse fundamentally shifts the discussion from passive anomalies to active processes. The magnetic field is not a geological remnant. It is an output that suggests function. It could be the signature of a sophisticated energy collection and storage system utilizing the sun's magnetic field, or it could be a simple, low-power communication beacon, a deliberate signal intended to demonstrate the object's non-natural status. The 4.7-second pulse, while seemingly arbitrary, stands as one of the most compelling pieces of evidence suggesting that we are observing not a rock from another solar system, but a machine from another civilization, a technological signature hidden in plain sight, beating out a steady, unnatural rhythm against the chaos of the solar system. The precision of the timing is the most difficult piece of data for the natural explanation to overcome. As Atlas emerged from its period of maximum thermal stress, another critical anomaly surfaced, one concerning the most fundamental measurement of all, its position in space. We have been tracking 3I/Atlas with extreme precision since its detection, employing highly refined orbital mechanics models that account for every known force: solar gravity, planetary perturbations, solar radiation pressure, and even the subtle non-gravitational push of expected outgassing. These models should predict the object's path with an accuracy measured in mere kilometers. Yet, at Perihelion, Atlas exhibited an unmistakable and significant trajectory deviation of 800 kilometers from its predicted orbital position. 800 kilometers is an enormous error margin in the context of high-precision orbital mechanics. This deviation is not a measurement error, nor can it be dismissed as simple calculation uncertainty. It represents a real change in momentum and required a measurable, sustained force to push the object that far off its gravitationally predictable path. For an object of Atlas's estimated size, a deviation of this magnitude demands a massive thrust component, a continuous, non-gravitational force applied over a period of days or hours. The force required is immense and should have left a massive, visible signature that was easily detectable by all major observatories. The problem, however, lies in the complete absence of the expected physical cause. In the case of a natural comet, any force that causes such a massive trajectory change must be the result of asymmetric outgassing, massive jets of material being ejected in the direction opposite the deviation. We should have seen massive, visible plumes or jets of material ejecting gas and dust in the direction opposite to the 800-kilometer shift. But we saw no such thing. The object moved without any visible propulsion, gliding silently off a predicted course as if guided by an invisible hand. This lack of visible exhaust directly challenges the conservation of momentum as we understand it in cometary physics. The failure to detect the required propulsion mechanism defies the fundamental law of momentum conservation. Where did the thrust come from? There are only three possibilities for an unpowered, non-gravitational trajectory change of this magnitude. First, a gravitational interaction with an unseen massive object, which is ruled out by the comprehensive coverage of our deep space surveys. Second, massive outgassing that we somehow completely missed, which seems impossible given the convergence of telescopes from around the world precisely at this moment of intense scrutiny. Third, the object maneuvered. It changed its path intentionally, utilizing a form of propulsion that does not produce visible exhaust. The trajectory deviation is, therefore, a signature of action without reaction, a physical impossibility under normal circumstances. It suggests the use of propulsion method that is highly efficient, invisible, and likely non-chemical. The deviation occurred precisely at perihelion, the moment of maximum energy availability and maximum thermal stress, suggesting that the maneuver was a deliberate course correction or specific action required by its internal programming. This unpowered shift is a final, compelling dynamic anomaly that screams a sophisticated, self-directing system capable of mastering its own inertia. The dramatic 800-kilometer trajectory deviation of 3I/Atlas at perihelion, occurring without the expected massive plumes of gas and dust, forces a direct confrontation with the issue of invisible propulsion. When a natural object changes its path, it must be subject to a force, and that force must, under known physics, produce a visible reaction, particularly in a volatile body like a comet. The fact that the object moved without visible exhaust means that the force generated was either incredibly efficient or derived from a non-chemical source entirely, a source we have not yet cataloged in our understanding of the universe. The difficulty in explaining this anomaly naturally lies in the concept of asymmetric heating. Even the smallest, most subtle changes in heating across an irregular cometary surface can cause tiny, continuous thrusts that accumulate over time. However, for such a minute force to generate an 800-kilometer deviation in such a short period, it would require a level of sustained, directed outgassing that should have been detectable. Moreover, the outgasser would have to be perfectly non-volatile and non-dust producing, which contradicts the spectroscopic evidence showing various gas emissions. This level of invisible yet powerful natural thrust is statistically implausible, requiring a coincidence of thermal properties that beggars belief. Therefore, the investigation must consider the forces we didn't see, the mechanisms that produce propulsion without the common signature of exhaust. This is a domain of advanced theoretical propulsion systems. One possibility is electromagnetic propulsion, utilizing the sun's strong magnetic field and the solar wind itself. The pulsing magnetic field detected by the Parker probe Chapter 10 could be the signature of such a system. The object could be generating a powerful, structured magnetic field that interacts with the solar plasma, creating a Lorentz force that gently, yet continuously, pushes the object off an expected course. Such a system would be highly efficient and would produce no visible exhaust, only the faint, rhythmic magnetic pulse detected. Another possibility involves the manipulation of solar radiation pressure. While solar radiation pressure is a known factor in orbital mechanics, an advanced system could actively and rapidly modulate its albedo chapter 8, or deploy massive, non-reflective surfaces to create a highly directed, non-visible thrust vector. By changing reflectivity on one side versus the other, the object could essentially sail on the photon wind, a subtle yet powerful force that could easily account for an 800-kilometer deviation over several days. The fact that the albedo shifted dramatically supports this highly specialized mode of propulsion. The trajectory change without visible exhaust is, ultimately, the smoking gun of active engineering. Whether through magnetic field manipulation or modulated photon sailing, the movement of Atlas suggests that it is not a passive vehicle, but an active participant in its own trajectory, utilizing the sun's immense energy field to perform control maneuvers. This transition from being a simple target of gravitational forces to being a subject capable of self-directed motion marks the most profound shift in the interpretation of the interstellar visitor, proving that its dynamics are governed by intention, not inertia. The sheer accumulation of anomalies, the inverse thermal behavior, the uniform surface temperature, the rapid albedo flip, the pulsing magnetic field, and the unpowered trajectory deviation forces a conclusion that is scientifically uncomfortable yet logically unavoidable. What if 3I/Atlas isn't a comet at all? What if it's a spacecraft? This interpretation, while extraordinary and requiring immense skepticism, offers a unified, coherent explanation for every contradiction observed during the Perihelion passage, an explanation that the standard model of cometary physics utterly fails to provide. The object shifts from being a geological puzzle to an engineering marvel. When interpreted through the lens of engineering, the previously contradictory data points suddenly become highly rational and consistent operational characteristics. Reduced activity at perihelion. This is not a contradiction of physics, but a protective action. A spacecraft experiencing maximum solar exposure would logically close protective ports or panels, or retract sensitive instruments to prevent overheating, hence the sudden shutdown of observable outgassing. The object is going into safe mode. Uniform surface temperature. This is no longer a geological impossibility, but a necessity for internal thermal management. To protect internal components, power systems, or delicate instruments, a spacecraft must maintain a stable, uniform operating temperature, achieved through internal heat distribution systems. Albedo flip. This becomes a form of thermal regulation. Deploying or reconfiguring reflective surface elements is the simplest way to reduce absorbed energy during maximum solar exposure, exactly as observed when the object doubled its reflectivity. The surface is a deployable shield. Pulsing magnetic field. This is not an unexplained cosmic event, but the signature of power generation or communication systems. The regular oscillations could be the duty cycle of a reactor or the rhythmic transmission of a low-power beacon, utilizing the sun's environment for power. Unpowered trajectory deviation. This transforms from an aerodynamic anomaly to a controlled course correction. The object utilized a non-exhaust propulsion method, magnetic sailing or photon pressure modulation, to subtly adjust its trajectory for a precise objective, perhaps observation or energy harvesting. The collective probability of natural processes conspiring to produce this entire suite of contradictions approaches statistical zero. Each anomaly, taken alone, might have a convoluted natural explanation, but all of them together, perfectly timed and executed at the point of maximum thermal stress, strongly suggest a single, unified, and functional system. The acceptance of this hypothesis is terrifying because it requires accepting that we are currently being visited by technology from another civilization, a probe, a vessel, or a highly advanced autonomous system. This is the moment where science must set aside its comfort zone and confront the data, no matter how uncomfortable the implications may be. The central argument against a natural classification of 3I/Atlas rests on the composite anomaly, the low statistical probability that all 10 observed contradictions could occur simultaneously in a single natural object. The scientific method demands intellectual honesty, which means acknowledging that while any single anomaly might be an undiscovered natural phenomenon, the combined timed occurrence of the entire suite of anomalies pushes the likelihood of a purely natural origin to a vanishingly small figure. This is the point where cumulative data overwhelms individual skepticism. The cumulative improbability is the key. Consider the chain of contradictions. Thermal contradiction. Maximum solar flux causes minimum activity. Chemical contradiction. Unknown spectral lines appear at the moment of shutdown. Geological contradiction. The surface temperature is impossibly uniform. Optical contradiction. The object doubles its reflectivity while simultaneously reducing outgassing. Dynamic contradiction. The object shifts its trajectory by 800 kilometers without visible exhaust. Electromagnetic contradiction. A small object generates a localized, pulsing magnetic field with precise 4.7-second period. To maintain the hypothesis of a natural comet, one must posit the simultaneous existence of an undiscovered thermal lag effect that causes a global, rapid shutdown, an unknown, exotic chemistry that only activates under stress, a single, homogeneous mineral that somehow possesses a spectral diversity of a varied compound, a mechanism for non-volatile reflectivity changes that is not dependent on sublimation, and an invisible propulsion source derived from non-chemical, natural means. The number of required unknown natural phenomena needed to explain Atlas is greater than the number of known phenomena it follows. The hypothesis requires a suspension of disbelief in favor of convoluted and proven science. This is the point where the scientific burden of proof shifts. While the official stance that there is insufficient evidence to conclude artificial origin is a conservative position, privately, the mathematics tell a different story. The data does not just show unusual properties. It shows a pattern of intentional regulation in response to the external environment. This pattern is the hallmark of technology. The composite anomaly suggests that we are observing not a chain of coincidences, but a coordinated system executing a high-level program. The sheer number of synchronized unnatural behaviors serves as a quantitative argument that the probability of natural processes producing this entire observational record approaches a mathematical limit of zero, leaving the hypothesis of artificial origin as the most statistically and logically consistent explanation. The scientific debate regarding 3I/Atlas, while publicly focused on cometary physics, has massive, immediate geopolitical implications that are being discussed at the highest, most classified levels of government and military intelligence. If the hypothesis of an artificial origin holds true, if Atlas is a probe or vessel from another civilization, then its presence transforms the object from a scientific curiosity into the most significant security and diplomatic event in human history. The stakes immediately shift from astrophysics to global security and power. The core concerns the motive behind the object's behavior at Perihelion, the regulatory shutdown, the energy harvesting, and the precise trajectory adjustments around the sun strongly suggest a mission of reconnaissance or data gathering. An advanced civilization would logically use the sun's gravity well and intense energy field for observation or to boost communications. This means Atlas might have been observing our star and, by extension, our solar system with a high degree of technological sophistication. This immediately raises questions of security. Is the probe detecting our radio emissions? Is it analyzing our technological output? Is it assessing our threat level? The implications of first contact, even with an unmanned probe, are profound. The nation that proved the object is artificial instantly achieves a geopolitical and technological supremacy that changes the global balance of power forever. Control over the narrative of first contact, control over the recovered technology, and the massive scientific leap that would result are incentives that dwarf any current arms race. This explains why major spacefaring nations are engaged in high-stakes, Internal discussions regarding a potential intercept mission, aware that the country that touches Atlas first could redefine the course of human history. Furthermore, the existence of such technology suggests a civilization with millennia of advancement beyond our own. This creates a state of existential vulnerability. Governments must secretly assess whether the object represents a benign scientific mission, a neutral relic, or a precursor to a more overt engagement. The geopolitical implications include the immediate need for a unified global protocol for contact, the reprioritization of military and space spending, and the intense internal pressure to be the first to reach and analyze the object. The scientific uncertainty surrounding Atlas is directly proportional to the level of classified anxiety it is generating within the world's power structures, transforming space agencies into security assets. To avoid the immense geopolitical anxieties that come with assuming a functional, watchful alien intelligence, two alternative, less threatening hypotheses regarding the artificial nature of Atlas have been proposed: that the object is either damaged or autonomous. These scenarios attempt to explain the observed inconsistencies in Atlas's behavior. The fact that it acts like a control system but does so in a seemingly erratic and contradictory manner. These hypotheses offer a psychological comfort zone for addressing the impossible data. The damage probe hypothesis suggests that Atlas is an aging vessel that malfunctioned millions of years ago, perhaps hit by a micrometeoroid or damaged by a massive stellar event. Its current behavior is interpreted as corrupted programming, failing systems desperately attempting to execute tasks under conditions they were not designed for. The irregular behavior and the inconsistencies, the magnetic pulse that doesn't quite match rotation, the albedo flip that's too slow to prevent overheating, the chemical signatures that flicker, could all be explained as failing hardware and software glitches. A fully functional, advanced probe would likely be far more subtle and completely undetectable. What we are seeing might be the equivalent of a dying machine throwing up random alarms as it executes a corrupted, outdated mission profile, its complex systems failing under stress. The autonomous relic hypothesis proposes a more melancholic possibility. Atlas is an explorer launched millennia ago by a civilization that is now extinct. It is a robotic explorer continuing its original mission profile, without operators or ground control. It is archaeological evidence of a species that rose to achieve interstellar capability, sent out its probes, and then vanished. Atlas is simply a lonely machine executing programmed tasks in a galaxy where its creators no longer exist. This hypothesis elegantly explains the immense time scale of its journey and its complete lack of direct communication. It is not watching us. It is simply continuing its programmed journey, a ghost ship from a distant dead civilization, a technological fossil of immense value. Both hypotheses allow scientists to investigate the object's potential artificial nature without immediately triggering global panic or military mobilization. They reframe the question from "are they watching us?" to "what can we learn from their technology?" while offering a more palatable scenario for humanity. Both hypotheses still require the acceptance that Atlas is not a natural comet, but a piece of ancient alien technology. The choice between these models will depend entirely on the object's post-perihelion behavior. Continued chaotic regulation suggests a damaged state, while a return to a stable, predictable glide path might suggest a fully autonomous system completing its programmed mission. If 3i/Atlas is indeed artificial and functional, its ambiguous behavior, its failure to communicate directly despite its obvious capabilities, must be intentional. This leads to the fundamental question of deliberate contact protocol. If a civilization possesses a technology for interstellar travel, why would their probe not simply transmit clear, unmistakable signals? Why remain silent and ambiguous, only revealing its nature through a series of subtle physical anomalies? The answer lies in the strategic approach to engaging a new species. One explanation is the surveillance drone hypothesis. Atlas's trajectory, which brings it close to our star for maximum observation, suggests a mission of reconnaissance. The probe may be gathering data about our technological level, analyzing our solar system's physical parameters, and assessing our potential threat level before more overt contact is considered. An advanced civilization may be following the Prime Directive, a non-interference principle that dictates long-term observation before engagement. From an advanced civilization's perspective, immediate, clear communication might be deemed reckless. They may have encountered dangerous or volatile species before, necessitating a long period of quiet observation. Atlas, in this view, is the equivalent of an unseen surveillance drone, testing the technological capacity of humanity to even detect its presence. The second explanation is the caution protocol hypothesis. This suggests that any civilization capable of interstellar travel has learned the necessity of a highly gradual, non-threatening approach to first contact. Direct, overt communication could be perceived as an invasion or a threat, potentially triggering a primitive, violent response from the recipient species. By remaining ambiguous, Atlas forces humanity to engage in self-discovery and scientific consensus. It creates a narrow window where we are advanced enough to notice something highly unusual, but not yet advanced enough to fully understand or capture it. The ambiguity itself is a test, a way to gauge our analytical capabilities, our intellectual honesty, and our readiness to accept the reality of others. The timing of Atlas's appearance is also highly suggestive. It entered our detection range just as we achieved the technological capacity to detect and study such subtle anomalies. A century ago, we would have missed it entirely. A century from now, our technologies might make its anomalies too obvious. The timing could be deliberate, an intentional probe execution that occurs only when the target civilization reaches a specific, testable level of technological maturity. Whether it's a surveillance drone or a careful opener to dialogue, the ambiguity of Atlas suggests a cautious, deliberate, and highly intelligent approach to the act of first contact, a quiet introduction to the true scale of the galaxy. Intellectual honesty requires that we rigorously present the most compelling counter-arguments to the artificial hypothesis. The possibility that every single anomaly observed on 3i/Atlas has a natural explanation that we simply haven't discovered yet. This perspective maintains that Atlas is not a spacecraft, but an extraordinary natural object, a phenomenon that forces us to expand our knowledge of cometary physics rather than accept an intelligent origin. It is a necessary exercise in scientific restraint. The reduced activity at Perihelion can be addressed by the thermal lag effect. This theory suggests that the subsurface material of Atlas has extremely low thermal conductivity. While the surface heats up rapidly, the heat does not penetrate deep enough to trigger mass sublimation of the deep ice. Instead, the initial heating might cause a temporary sealing process, where dust particles fuse together into a thin, temporary crust that acts as an insulator, momentarily reducing outgassing before eventually cracking later. This would create a temporary, paradoxical shutdown. The uniform temperature anomaly is harder to explain, but proponents of the natural view suggest that internal convection of gases through a highly porous interior or the presence of an exotic, crystalline form of ice could distribute heat more evenly than predicted by current models. Although the rotation rate is too slow for simple heat distribution, there might be internal geological processes we are not accounting for, such as heat transfer driven by the volatile gases themselves. The albedo flip could be the result of a delicate frost formation. Counterintuitively, as the object approaches the sun, the intense heating could cause surface volatiles to sublime, but the local pressure and temperature conditions immediately around the object are correct. That vapor could recondense on the surface as a temporary, highly reflective frost layer before being dissipated. Alternatively, intense UV radiation could alter the surface chemistry of certain carbon compounds, causing them to oxidize or reduce, thereby altering their reflectivity. The pulsing magnetic field remains the most difficult challenge, but even this could be theoretically explained by exotic geology. If Atlas contains metallic core fragments from a destroyed protoplanet, the intense solar wind interaction, combined with differential heating and cooling, might create complex thermoelectric currents that produce a naturally oscillating field. The trajectory deviation could be attributed to highly subtle, non-visible asymmetric outgassing, jets of material ejecting in directions we are not observing well, or the cumulative effect of highly efficient, non-dust-producing gas. The natural counterargument asserts that our understanding of how volatile ices behave in low-density aggregates, especially those from outside our solar system, is incomplete. Atlas is showing us new natural phenomena, not artificial ones. The ambiguity of the data is a testament to the complexity of the universe, not the presence of aliens. Both interpretations are scientifically viable, and the current moment is defined by the absolute uncertainty that exists between them. The Perihelion passage of 3 I/Atlas has served as a cosmic catalyst, giving humanity new data, new questions, and an acute awareness of the limits of our knowledge. Whether the object is an exotic natural phenomenon or a piece of sophisticated alien technology, the overwhelming truth is that we do not know, and we are running out of time to find out. Atlas is now past Perihelion, moving away from the sun and rapidly heading back into the cold, outer reaches of the solar system at a velocity of 20 kilometers per second. Every hour we debate and delay, the object travels another 72,000 kilometers further away, compounding the difficulty and expense of any potential follow-up mission. The lack of certainty is itself a call to action. We cannot definitively prove Atlas is artificial, and we cannot definitively prove it is natural. This ambiguity is precisely why we must act. If Atlas is natural and we fail to study it, we miss a once-in-a-lifetime opportunity to expand our understanding of how materials from other star systems behave, what their chemistry is, and how they challenge our most fundamental physical laws. If Atlas is artificial and we fail to investigate, we miss the first and possibly the only physical contact with another intelligence in our lifetimes. Both possibilities are too important, too profound in their consequences, to ignore based on institutional caution or internal scientific squabbling. The technology for a mission exists. A fast flyby probe could be launched within months. A rendezvous mission, which will provide the necessary close-range imagery, direct sampling, and magnetic field analysis, would take longer but yield vastly more conclusive data. The problem is no longer technical. It is political and financial. We are in a position where the most important potential discovery in human history might be allowed to simply glide away because the global community cannot agree on the official justification for funding. The official position of Unusual Comet is a politically safe barrier to the funding required for a world-changing discovery. The responsibility now falls to humanity to make a choice. The data from Perihelion demands a direct investigation. We must overcome the certainty on both sides, the overzealous belief in the artificial and the dogmatic insistence on the natural, and dedicate the resources required to chase the truth. Atlas has offered us an unprecedented gift, a chance to learn, a chance to grow beyond our current limitations. The question that haunts every astronomer, every physicist, and every citizen is whether we are wise enough to seize this chance before the interstellar messenger passes out of our reach forever. The next few months will define whether we choose caution or courage in the face of the unknown. The ultimate revelation of 3 I/Atlas depends on a rendezvous mission. Do you believe the geopolitical risk of confirming alien technology is worth the hundreds of millions required to launch a probe, or should we wait for more data? Let us know your thoughts and your chosen path forward, natural or artificial, in the comments below. If you want to follow the final desperate scramble for a mission to Atlas, don't forget to like, subscribe, and join us as we race against the clock to catch a machine from the stars.